Neptune collision detected. NASA's Voyager 1 spacecraft, the furthest traveling spacecraft ever launched, continues its breathtaking journey through the cosmos. For nearly 50 years, Voyager 1 has been sending back crucial information from the farthest reaches of the universe, significantly advancing our understanding of the cosmos. However, recent transmissions from this remarkable spacecraft have presented perplexing signals that have left the entire space community in a state of awe and bewilderment. These signals have sparked debates about whether they are the result of a technical glitch or if they could be indicative of something far more extraordinary, such as extraterrestrial activity. Join us as we delve deeper into the mystery surrounding these remarkable transmissions and uncover what might be lurking in the depths of space. Humanity's fascination with the mysteries beyond our planet has been a driving force in space exploration since its inception. This insatiable curiosity led to the historic launch of missions like Explorer 1 and Explorer 2, which were among the most ambitious space endeavors of their time. The launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just 14 days later, on September 5th, Explorer 1 followed, setting the stage for an unprecedented journey. These twin spacecraft, each weighing approximately 720 kilograms, roughly equivalent to a small car, were launched during a rare alignment of the outer planets, which played a crucial role in their trajectories and mission outcomes. Throughout their remarkable odyssey, these spacecraft traveled in divergent directions and at varying speeds. A pivotal moment occurred on December 15, 1977, when Explorer 1 surpassed its twin due to differences in their paths. Since then, Voyager 1 has emerged as a vital asset, providing invaluable information that has revolutionized our understanding of the cosmos and its myriad phenomena. Before we dive into Voyager 1's latest astonishing discovery, which has captured the attention of the entire space community, let's revisit some of its most remarkable achievements. In 1978, during its Jovian imaging mission, Voyager 1 was positioned about 265 million kilometers from Earth. By January 1979, it had embarked on an exceptional 100-hour mission, capturing a mesmerizing time-lapse film of Jupiter's rotation. This series of 3,750 images offered unprecedented views of Jupiter's dynamic atmosphere and its complex features. The spacecraft's findings included the discovery of a small ring around Jupiter and 2 previously unknown moons, greatly expanding our knowledge of the gas giant's intricate system. To ensure the spacecraft's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn mission, researchers decided to conclude the planetary mission of both Voyager 1 and Voyager 2. However, the spacecraft were sent on a new trajectory beyond the confines of our solar system, traveling at an astonishing speed of 325 million kilometers per year. In January 1990, the interstellar mission began with Voyager 1 continuing its celestial journey. During this period, Voyager 1 made significant discoveries, including the identification of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most iconic images ever taken of our solar system. On February 14, 1990, Voyager 1, positioned approximately 6 billion kilometers from the Sun, embarked on a visual excursion known as the Family Portrait, capturing stunning images of the solar system's planets. This collection of 60 images added to Voyager 1's impressive portfolio of 67 photos taken during its encounter with Neptune. Voyager 2 also achieved remarkable milestones during its mission. As it approached Neptune, it recorded wind speeds exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. This achievement provided invaluable insights into Neptune's distant atmosphere and its largest moon, Triton. Triton's surface temperature drops to a frigid minus 391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also exhibited unique features, including ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its hazy atmosphere. These extraordinary findings have deepened our understanding of the diverse and complex nature of celestial objects in the outermost regions of our solar system. The Voyager missions have delivered profound and transformative results. Voyager 1 and Voyager 2 have revealed that Jupiter and Saturn's moons, once thought to be heavily scarred and inactive, are actually brimming with geological activity. Voyager 2, in particular, achieved several historic milestones, including being the first spacecraft to fly past Uranus and Neptune, and remains the only spacecraft to have done so. NASA employed various strategies to extend the operational lifespan of these ambitious spacecraft, including shutting down non-essential heaters and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a touch of melancholy for the scientists and engineers who have dedicated themselves to this extraordinary endeavor. The design of Voyager 1 and Voyager 2 was a marvel of engineering. These spacecraft were designed as stable platforms, rotating at a rate more than 15 times slower than a clock's hour hand. This design choice reduced visual blurring as the spacecraft traversed the vast expanse of space. Even before reaching the outer planets, the spacecraft began transmitting images of Jupiter, revealing its swirling clouds and iconic features. The Great Red Spot, a massive storm on Jupiter, captivated audiences at NASA's Jet Propulsion Laboratory. However, the discovery of active volcanoes on Jupiter's moon Io garnered the most attention. The spacecraft's instruments detected unusual signals from Io, which were confirmed by unique images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 10 times greater than that of Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power and memory before they ventured into interstellar space. Notably, the images they captured did not include Mercury and Mars for various reasons. Besides the Explorer probes, NASA has launched other notable spacecraft, including Voyager 10, Voyager 11, and New Horizons. On February 17, 1998, Voyager 10 surpassed Voyager 11, becoming the spacecraft farthest from Earth. Despite the absence of other space probes to witness it, Voyager 1 continued its solo journey for an additional 14 years before entering the interstellar environment on August 25, 2012. The success of the Voyager missions was made possible through various innovative techniques, with gravity assist maneuvers standing out as particularly brilliant. These maneuvers were crucial for propelling the spacecraft to their distant destinations and collecting valuable data. The spacecraft relied not only on their own propulsion systems but also on gravity assists to achieve their objectives. Imagine the two fearless rockets gracefully navigating through our local planetary system, utilizing the gravitational pull of planets to propel themselves forward. This celestial dance allowed them to conserve fuel and achieve the necessary speeds to visit different locations. Gravity assist maneuvers involve providing the spacecraft with a small amount of a planet's energy as it passes by with extreme precision. For example, as Voyager 1 approached Jupiter, the planet's significant gravitational attraction accelerated the spacecraft, increasing its velocity. Achieving such precision was crucial. Any deviation from the correct angle or speed could have resulted in a disastrous outcome. Despite the daunting accuracy required, the brilliant minds behind these missions successfully executed these gravity assists multiple times, sending the spacecraft on an extraordinary journey. The Grand Tour, made possible by these celestial maneuvers, saw Voyager 2 utilizing gravity assistance from Jupiter and Saturn to reach Uranus and Neptune. The success of the Voyager missions owes much to these gravity aids. As we reflect on the incredible journey of these trailblazing spacecraft and the wealth of knowledge they have provided, we eagerly await further updates on the investigation into Voyager 1's recent anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond earthly bounds, and their accomplishments include Jupiter and its moons, Saturn and its moons, Uranus, and Neptune. Voyager 1's time-lapse images showcase 10 rotations of Jupiter in vivid detail, including the discovery of new moons and a small ring. These findings have greatly enhanced our understanding of Jupiter's complex system. Voyager 1 also discovered 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took remarkable photographs of Saturn and its rings, providing new insights into Saturn's intricate system. The spacecraft made history by visiting Uranus and Neptune and providing valuable information about their atmospheres and moons, enriching our understanding of the outermost regions of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the cosmic environment. This ongoing exploration continues to expand our knowledge of the universe beyond our solar system. As we await more information about Voyager 1's latest signals and their potential implications for our understanding of the cosmos, the remarkable journey of the spacecraft remains a source of inspiration and fascination for scientists and space enthusiasts alike. Their groundbreaking achievements continue to push the boundaries of human knowledge and exploration, highlighting the boundless potential of space discovery. The Voyager missions have provided us with a treasure trove of information about our solar system and beyond. Beyond the iconic images and data, the spacecraft have also carried a golden record, a unique artifact designed to communicate the story of our world to extraterrestrials. This record contains sounds and images chosen to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds like thunder and whale songs. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they might find and understand it, offering a glimpse into humanity's essence. Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our knowledge. These instruments included magnetometers, plasma wave detectors, cosmic ray instruments, and imaging systems, each contributing crucial data about space phenomena. For instance, the magnetometers have provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surrounding environments. The plasma wave detectors helped us understand the nature of the solar wind and its interaction with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that encloses our solar system. As Voyager 1 approached the edge of this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in shielding Earth from cosmic radiation. The spacecraft's observations have provided evidence of a distinct boundary, where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally groundbreaking. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide valuable data on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly notable for revealing its unique magnetic field, which is tilted significantly compared to the planet's rotation axis. This discovery challenged existing models of planetary magnetism and spurred further research into the magnetic environments of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the personal stories of the spacecraft's journey, have captured the imagination of people around the world. The images of Saturn's rings and the detailed views of Jupiter's moons, especially Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. These missions have fostered a sense of wonder and curiosity about the universe, highlighting the importance of exploration and the quest for knowledge. The engineering and logistical feats achieved by the Voyager missions are also worth noting. The spacecraft were designed to operate in extreme conditions far from Earth, with temperatures dropping below -2,200 degrees Celsius. They rely on radioisotope thermoelectric generators, RTGs, for power, which provide a consistent energy source despite the vast distance from the Sun. The engineers who designed and built these spacecraft faced numerous challenges, including ensuring that the instruments would remain functional for decades and that communication could be maintained over such immense distances. The data returned by the Voyagers has also influenced our understanding of the broader cosmic environment. The spacecraft have helped to map the distribution of cosmic rays and have provided insights into the density and composition of interstellar dust. This information is critical for understanding the conditions in the space between stars and for preparing future missions that might explore other star systems. As the Voyagers continue their journey into interstellar space, their legacy is cemented not only by the data they have already provided, but also by the inspiration they offer for future exploration. The missions have paved the way for new technologies and methodologies in space science and have set a precedent for ambitious long-term space missions. They demonstrate the possibilities of human ingenuity and the value of perseverance in the face of daunting challenges. Looking forward, the Voyager missions have inspired a new generation of spacecraft and mission concepts. Future probes aim to build upon the Voyager's success, with the goal of exploring even more distant regions of space. These upcoming missions will continue to push the boundaries of our knowledge and will benefit from the foundations laid by the Voyager spacecraft. In conclusion, the Voyager missions represent one of humanity's greatest achievements in space exploration. Their contributions to science, their role in advancing our understanding of the solar system and beyond, and their impact on public imagination underscore the importance of continued exploration and curiosity. As Voyager 1 and Voyager 2 journey further into the cosmos, they remain symbols of human aspiration and the endless quest for knowledge.